Workbook. Maths part 2. Breakfast. Yeah.
Woke up early.
Too early?
7.
It's okay. Oops. Okay, we'll start. So last time we saw the standard normal distribution. So this one we're going to look at is just called the normal distribution. And we say that the mean average of the normal distribution is at mu, and the standard deviation is sigma. So often we write it like this. So if I write this, it means a bell curve histogram with... Hey, do you have the key or something?
No, I'm looking for my students. The classroom has been changed.
Which group now? Is this January or September?
January.
Now, I saw a whole bunch of those January students outside Sylvia's office submitting stuff.
Okay.
So if they're not in the room, it might just be because they're delayed with that.
Right, okay.
Yeah.
Cool. Thanks.
With mean mu, did you draw the picture? No. With mean mu and standard deviation. My goodness, I'm not even sure how to spell deviation. Too early. DE. Deviation sigma.
That's why it's in n mu sigma squared.
Yeah, this is just the way that they write for short. Bell curve histogram with mean mu and standard deviation sigma. Now the reason for the M, you can probably guess what the N stands for. Normal. So, and the reason for the square is complicated for us. We don't have to worry about it. So yesterday we did this one. Average 0, standard deviation 1, which is just 1. That was yesterday's. And then this one is today's. So there's not much of a difference. Got that? Can I scroll down? Okay, so let's have a look at an example here. So let's say we talk about people's heights. What would be an average height for people?
160, 170.
So I would say average here 160, and this is height in centimeters. And most people are between what two heights, would you say? Like what would be a small height and what would be a tall height?
155.
155, I think maybe like 140 maybe.
No, for baby.
Maybe a little Chinese student, you know? And then maybe up to 180. So what would the standard deviation here be, roughly? What would you say?
160.
Standard deviation. The average is 160. Standard deviation?
20.
Nearly. 10. Why 10?
5.
Yeah, but why divide by 2? Because I said roughly 2 standard deviations wide. Yeah? Okay, so you might say, okay, how tall are you?
160.
Okay, we'll say 165. So here's 165. So you might want to know how many people are shorter than you. So then you want this area. Hey. Okay. So for this example here, you missed this slide here, so if you want to start writing this one down, this example. What was I saying? Oh yeah, so you might want to know how many people are shorter than you. So you would want to know this area. Yeah? The percentage of people. Why can't I use the table book for this?
That's my question.
What was your question going to be?
Why we don't use the previous lesson sources? Like the
Yeah, but how? Because the table book was a table for this, where the center is 0 and the standard deviation was 1. We need one that has a center of 160 and standard deviation of 10. Do you get what I'm saying? It's a different curve. So what do we do? Well, what we do is we use something called the Z transform. And it's a way of changing this number, and this number into numbers on the graph we did yesterday. Because what we really want is we want this to be 1. And what we really want is this to be 0. So then this has to become some new number. I'll call this new number Z. And I'll call the old number, I'll call it X. And we'll say it's 165 centimeters. Okay? The Z transform is this formula.
No,
Yeah.
the X is like 1.1 for the
Maybe something like this. Yeah, we'll calculate it exactly. Z equals X minus mu over sigma. If you use this formula to change your numbers, what will happen is your standard deviation will automatically become 1, your average will become 0, and your Z will become 165 minus 160, which is 5 over 10, which is 0.5. So now you just have to look this one up. There's 0, there's 0.5. So our answer for this area is phi 0.5. Using a special formula called the Z transform. You've seen this before? But it makes sense?
Yeah.
Good. Okay, can you open up the formula book? And I'll open it up too. And we'll see what I don't think we've done 0.5. Let's see what we get. Typically, section A and section B both have a probability and statistics question. This would be usual. Where's my formula books gone? Resources. Syllabus and formula books. Engineering's formula book. Okay, so 0.5 is 0.6915. So that's 69.15%. So, Mushari, 69.15% of people then will be shorter than you in this example.
Say 65?
No, it seems unbelievable.
I'm taller than 65 of the
Population, yes. Let's do another example. Do you need to write this one? You do need to write this one down.
I want to open the formula.
Oh, okay. But Adnan's waiting for you to write this down. Because you wrote this down. Yes. We'll do another example. Got that? Okay, let's do another example. Have you ever heard of IQ?
exam.
The exam? Yeah, the test. Is that what you mean? Adnan? Have you ever heard of IQ? A person's IQ? Yeah. So the way IQ works, it's designed so that the average IQ is 100 points. So on average, this is what an average person would get. Sharif.
Well, no, really not.
Okay, but what's taking so long?
I'm not fine.
Oh, come here. Look. What? No, firstly, you're in the wrong book. Wrong folder. Okay? Look. It's down here under resources. Books and resources. Formula book. Click. Last page.
PDF, so I can't.
Your phone is weird.
Yeah.
Okay. Your phone can't open PDF? Well, you know what? Actually, come back here. Can you go to Google? We can get a different formula book up on Google then. Have you got Google open? Right. So I need to type in normal distribution table. Here we go. There's the table. Okay. Right, so as I was saying, IQ average is 100 points, and so mu is 100, and the standard deviation for IQ is 10. So that means most people are between, not everybody of course, but most people are between 80 and 120. So this is typical. So let's say we'd like to calculate how many people are more than 130, we'll say, as an example. So we have to Z transform. So when we Z transform, The Z transform takes the average to 0 as is normal, the standard deviation to 1 as is normal, and Z becomes 130 minus 100 over 10. The formula, remember, was x, x minus mu over sigma. So what's that now? That's 3. Yeah. So now what we're looking at is the area to the right of the tree. It's given. Here, yeah. I'm using this formula. Okay, so what was I saying? Oh yeah, so we want the area bigger than 3. So that's equal to 1 minus the area less than 3, which is 1 minus phi 3. Phi 3, yeah. So if we look in our table book now, phi 3 is 0.9987. So that would be 0.0013. So that's not even 1%, because 1% would be 0.01. So that's like 0.13 of a percent. You know, so that's like, what we say, about 1 in 600 people would be in this group of IQ, 130 or greater. The reason I picked 130 is because 130 is classified as a high IQ. On the other side, down here, at 70 or less, that's considered a low IQ. Okay, now that we have the basics, let's look at an engineering example. Yeah? Can I? No, not just. Yes. Yeah? Okay. Scrolling down. So, the reason this is important for you in engineering is because this comes up a lot in manufacturing. So I'll give you an example, a simple example just to get the idea. So you're in some factory perhaps, and it's manufacturing, we'll say, bolts or something like this, I don't know, whatever. And if the bolt is too big, then we reject it, it's not suitable, and if it's too small, then again we reject it, it's not suitable. So let's say on average the width, we'll say, I don't know, is 25 millimeters, we'll say, something like this. And the standard deviation, we'll say, is 2 millimeters. That might be too big actually, 1 millimeter. Okay. And if the bolt is too big, so if the bolt is more than or equal to 27 millimeters, or if it's too small, if the bolt is less than or equal to 23 millimeters, then we reject. We discard, we throw it away. So the question is, how many bolts, what percentage of bolts will be rejected? So we can draw our bell curve. The average is 25, and we reject when it's smaller than 23, which is this part here, or bigger than 27 here. So we want to know how many do we reject. Okay, well, if we do our Z transform again, this becomes 0. This one here becomes 23 minus 25 over 1. So that becomes minus 2, and this one becomes 2 when you calculate it. So we need this area and this area.
The area between them.
Yeah, we could get the area between them. I'll just do it the long way. So this area and this area. So this area here will be phi minus 2 plus, and this area here will be 1 minus phi 2 because it's to the left there, yeah. This is 1 minus phi 2 plus 1 minus phi 2. I think I have that okay. So that would be 2 minus 2 phi 2, which would be 2 minus 2, and then phi 2 is 0.9772. I think I did something wrong here. Did I? No. What is this actually? This is too big, isn't it?
More than one.
Yeah, that's a problem. It's 2. No, actually, this is 2 times 1 minus 0.97.
1.9544. When you multiply 2 by 0.977.
Oh yeah, but give me the final answer here. Type this in. .0. Okay, so it's okay then, yeah. So it's a 4.56% then. So that's how many bolts get rejected because they're too big or too small. So for example, if we make, let's say we make, I don't know, let's say we make 2,000 per hour. Then how many do we reject per hour? That's 0.0456 times 2,000 rejected per hour. As an example, what would that number be? It'd be like 92 or something.
91.
Okay, 91.2. So we'll 91 rejects per hour. Example part B, example part A. Okay. You have this, guys? Yeah? Okay. Can I scroll down? Okay, let's have a look at another example. So let's say, for example, you're measuring voltage, and let's say you measure it at something like, I don't know, 16 volts, then you measure it again and you get 15 volts, then you get 16 volts, then you get 17 volts, then you get 16 volts, then we get 14 volts. How many is that? 1, 2, 3, 4, 5, 6. And then we measure it one more time and we say we get 15 volts. Okay, that's enough then. So let's have a look at some questions here. So part A will be to calculate the mean. Part B, calculate the standard deviation. And then part C, so what's the biggest number here? 17, isn't it? Yeah. How often will the voltage be more than or equal to 18 volts? Now this is a good example of how useful this topic can be, because if you look at your data, how often did we get 18 volts? Never. But that doesn't mean we won't get 18 volts because we just don't have enough data. Do you understand? Because we only have 1, 2, 3, 4, 5, 7 points. But maybe in 20 points we could see one of them is 18. Do you understand what I mean? So this is one really powerful use of this, is that with a limited data we can sort of make useful conclusions and results. But before we can calculate that, we need to know the mean and the standard deviation. The first thing, I'll give you a couple of minutes to try this before I do it. ABC, mean first, standard deviation second. And if you forgot the formulas, which I hope you didn't, the mean is you add up all the data and divide by n, and the standard deviation is square root, divide by n, and then you add up the data minus the average squared. Yeah, okay, so if you can try that please, and then I'll do it now, once you're finished. Come on, Adnan, don't you want to try? You know how to calculate an average now, don't you? Oh, you said you did A. Well, I have the formula there for the standard deviation.
Can you remove that one?
Oh yeah, sorry. I know it's not as exciting as Clash of Clans, but you know, probably more important to you. Any luck getting that? Standard deviation part?
What's the result then?
Yes.
So it's only the
Yes. Musharif, you got the answer yet?
Just want to look up in the
Sure, great. What answer did you get? What percentage?
0.28.
Oh, smaller than I thought. 0.28% or 0.28?
0.28.
Let's have a look. So the first thing was to calculate the mean. Well, that's okay. What's the first one? 16, is it?
16 plus 15 plus 16.
Like this? Divided by 7, and we get 15.42, yeah, roughly. So the mean is about 15.43. Not what you got?
I guess 15.6.
Oh dear, we shouldn't all get different answers.
The add is 109, not 108.
Yeah, around 100.
Okay, let me check again. 16 plus 15 plus 16 plus 17 plus 16 plus 14 plus 15. Uh-huh. Uh-huh.
My calculator says
Then you move that calculator.
16. No, watch me. Tell me what I'm doing
Watch
wrong.
me, yeah.
No, watch me. Tell me what I'm doing wrong. Is the first one 16?
Yeah,
The second one?
16.
Next one? Next one? Next one? Next one? Next one? Is that them all? How many numbers are there?
7.
I'm hitting the number
What?
for 9.
Oh. Interesting. 15.57. Thank you very much. Okay, now we've got to watch the standard deviation carefully. So it's square root fraction, and on the bottom is 7. And on the top we have a square. And we have answer minus, the first one is 16. Plus answer minus 15 squared. Now to save time, how many 16s do I actually have?
3.
Three.
You already did 2.
No, I did 1. No, but I already did 1. I'll just put a 3 here. So I don't have to type it 3 times. And then how many 15s do I have? 2, yeah? So I don't have to type it 2 times. What else have I got? A 14 and a 17, yeah?
Which is the same difference, so you can also.
That's a good idea. I'll type it the long way though, but I do like your idea, it will work. This is 14. No, it's not the same difference from the average.
Yeah, you square it. The difference.
But the average isn't...
The difference between 15.5 and 17 is 1.5, and 14 is minus 1.5. And when you square
But it's 5.7. Okay, no, I believe you.
The same difference.
Okay.
I took it only to 1 decimal place.
Ah, I'll be a little more accurate. Yeah. I have 114 and 117, is that right? Yeah. Right, so standard deviation is... Oh, no, be careful. Standard deviation is this. 0.904.
Yeah.
Okay.
2.9.
Right, now let's draw our bell. So we have our average and our standard deviation, and we want to know how many more are, how much is more than 18. So we need to transform it into 0, 1, and this won't be 18 anymore. Z will be 18 minus 15.57 over 0.904. Yeah, 2.69 we'll say. So this is 1 minus that, which is 1 minus that, zero, 1, 2, 3, oh, 9 is at the end, of course. 9964 in this case. .0036. Which equals 0.36%. And that's it. So about 1 in 300 voltages will be more than or equal to 18. That's something you couldn't know unless you actually measured it 300 times or whatever. But we don't need to measure it 300 times. It was enough to measure it 7 times and conclude that 1 in 300 voltages will be more than 18 then. So again, I'm trying to show you how powerful this theory is, how useful it is. So can you write this one down, please? Yeah. 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 Yes. It's pretty good. Yeah. Most situations follow this nice bell curve. Yeah.
Stephen, I have a question.
Yes.
CIG has massive down before the interview.
Is it?
Before, yeah.
For you too?
Yeah.
Are you sure it's for you? Are you sure? Because sometimes they have this math entrance test for like mature students or students that have been out of school for a while. You know what I mean? What do you mean how? What do you mean how? What's your question?
Like which is
Like somebody who's like, I don't know, 26 or something. How old are you?
21.
So, don't think they'll ask you to do this test at 21. We'll have to ask Porrick or something, but I wouldn't worry about the test, because I've seen the test. Trust me when I tell you that what you do in this class is more difficult than this test.
But I thought the exam would be enough.
It should be. Where did you hear this about the test?
When I did the application form and I gave them my number, they called me saying you have to apply for it.
When was this?
Maybe because your high school is a long time ago.
Yeah, well that's what I'm saying. But he's only 21. I don't know at what age did they start making students do. Do you know what? Go to Google and type in University Mature Student Ireland and see what age you get. This would be the reason why, Adnan, they would have you do things like this. I thought it was 24.
University Mature Student?
Ireland age, something like this. Or you could phrase it as a question: what is the mature student age in Ireland for university? Did you get an age?
What is the spelling
For what?
maturity?
M-A-T-U-R-E. Did you get an age on man?
Yes.
23.
23 years.
23? And you're 21?
Over 23.
Yeah. Did you talk to Park about this? Maybe it's a mistake. Oh, sure?
No. Yeah.
Ah, well that's what you should do. When did you get this phone call?
Okay.
Last week? Okay. You should send him an email, or your tutor an email, or your course leader an email. Who's that? Lorraine?
No.
Connell. So either Isabel, Connell or Porrick, one of the three people you should email.
Always.
Yes. Wait, well actually hang on, no, second question. Your DIT application, did you do that through us or by yourself?
I can do it through you.
No.
The bill gave me that.
Yeah, but who did you do the application with? Us or by yourself?
How can I do it with you?
In other words, did we give you the application
Yeah.
form? Yeah, okay, that's what I mean.
No. The bill gave me the website of the IT.
And did you put in all the details about the IFC?
Yeah.
Yeah?
Yeah.
I think it maybe is a mistake, because usually students don't have to do entry tests unless they're maybe mature students.
23 years old.
Yeah.
If it's not a mistake, then I think it's because we graduated high school early.
Oh, the time since high school. How many years ago since you were in high school?
I finished it
2012. 2012, and this is 2017. 5 years ago. Maybe this is the reason. But trust me, it's actually good, because this test is not very difficult. In fact, this test is more difficult than that test.
But it's both a test and preparation and really more study and 2 days of tutorial in the IT.
Oh, they make you go to a tutorial as well?
Yeah.
I don't know, this sounds very strange. You better try and fix this. And do you have to pay for this tutorial and test? Maybe it sounds like they're trying to get extra money from you. I'd better check this. Because maybe someone saw your application and said, oh, 5 years, you better do the entry test. Maybe. But you're right, because you're applying with us, you shouldn't have to do things like this. The only time students have to do entry tests here is when they go to medicine, or sometimes hotel management. They have you do like sort of an interview, practice your skills with people. You shouldn't have to for engineering, so you should check that, okay? Alright, did you write this one down? Did you write this down? Yeah, okay. Let's have a look here. Okay. So we got a lot of questions I made for you here. I know. So why don't you take a 5-minute break? 5 minutes only. And then we'll come back and we'll look at these, okay? But seriously, only 5 minutes, because I want to finish a few minutes early today because I have to go somewhere.
I want to go home with the bus.
Okie dokie. Sounds good to me. And you are just going down for a cigarette, okay? Just the one cigarette, right?